Hey pre-calc, today's assignment is this worksheet of graphing exponentials and logs. And I know you've done this already, but I thought I would work a few with you in case you needed a little bit of guidance. If you feel good on that worksheet by yourself, you don't need to watch this. But I am going to work question 1 on the front as well as question 9 on the back, or the second page, I should say. All right, so let's take a look at question 1. If you don't have it printed out in front of you, please go ahead and copy the chart I have. And this video is not going to have any forced pauses or anything, so we're just going to walk through these, but do go ahead and pause on your own if you don't have this in front of you yet. Okay, so I'm actually going to start over here with the transformations of the parent function. So in this case, the parent function is just 2 to the x, and then the minus 1 is the transformation. So the transformation is that I've gone down 1. So really think about your exponential parent function, right? No matter what the base is, as long as it's greater than 1, it always goes through the point 0, 1, and then grows this way, and then it's got this asymptote of the x-axis, or y equals 0. So that's what the parent function is. We're taking that function and shifting it down 1. Okay? All right, then I like to go to my 2 points. It says 2 points. I oftentimes do 3 or 4 just to get a good picture of what the graph is doing. So let's start at x equals 0. When x is 0, my output is going to be 2 to the 0 minus 1. Let's just write that. Cleaning that up, 2 to the 0 is 1. Anything to the 0 is 1. 1 minus 1 is 0. So I have the point 0, comma 0, which makes sense because the parent function has the intercept, y-intercept at 1, and then I'm going to shift that down 1 for this graph. Okay, let's do another point. Let's try x equals 1. So then my output is going to be 2 to the 1 minus 1. Well, 2 to the 1 is 2. Minus 1 is 1. So I've got the point 1, comma 1. And again, I like to just do one more to get a feel for how quickly that graph grows. So let's test x equals 2. Well, 2 to the 2 is 4. Minus 1 is 3. So 2, comma 3 here. Okay, let's talk about asymptote. Again, the asymptote for the parent function was the x-axis, y equals 0. I've shifted down 1, so now my asymptote is y equals negative 1. Make sure you are giving me an equation of a line there, not just a number like negative 1. Okay? All right, I think this is enough to go off, so now we can kind of draw the graph, connect these points, something like that. Okay? All right, domain and range. Domain for exponentials is always going to be all real numbers. We do need to be careful for our range. Notice that the lowest that approaches y equals negative 1 doesn't actually reach that, though, so we'll do parenthesis, and then it goes up forever. So negative 1 to infinity. All right, and behavior. Since your domain is all real numbers, your limits are going to approach positive infinity and negative infinity. So let's do positive infinity first. That's going to the right. As I go to the right forever, the y's go up forever. And then let's do the limit as x approaches negative infinity of f of x. So as I go to the left forever, notice the y's in this case get closer and closer to negative 1. They don't go down forever, right? So we approach negative 1 there. Okay, so that is question 1 worked out. If you need some more time on that, just go ahead and pause. Otherwise, let's move on to question 9, okay? All right, again, the second page is log graphs, okay? So again, I'm going to start with transformations of the parent function. Parent function in this case is log base 2 of x. Remember, logs, the parent functions look kind of something like that, okay? In this case, I've taken the parent function, log base 2 of x, and shifted down 1 again. So I'm going to put D1. Let's go ahead and now move to 2 points. So for 2 points for logs, if we want a nice output, here's my recommendation. Start with what x value will make the stuff in parentheses be 1. Okay, well in this case, the stuff in parentheses is just x. So let's try x equals 1. So if I plug in 1 for x, my output becomes log base 2 of 1 minus 1, right? So I've got 1 comma. Now log base anything of 1 is what? This is 0 because this, remember, log identifies the powers. This is saying 2 to what power is 1. That's why I really like making the inside be 1, because then this part is always 0. Then I've got 0 minus 1, that's negative 1. Okay, so I've got the point 1, negative 1. Again, that makes sense because my original had an x-intercept at 1, so now I'm going to move that down 1. Okay. All right, let's try another point. After you make the inside be 1, then you move on to the base, and you're just going to do powers of the base. So you're going to start with 2. So I'm going to let x be 2. So that's going to give me log base 2 of 2 minus 1. Okay, well, log base 2 of 2 is 1. Remember, this is 2 to what power is 2. So this is 1, and 1 minus 1 is 0. So I've got the point 2 comma 0. Let's do another. Let's keep moving with powers of 2. So the next power of 2 would be 4, right? So when I plug 4 in, I get log base 2 of 4 minus 1. Okay, log base 2 of 4 is 2, because again, this is 2 to what power is 4. So this is 2, 2 minus 1 is 1. See how slowly these grow? Right? If I wanted to keep going, my next x value I would test is the next power of 2, which would be 8, right? That is 2 to the third is 8, okay? All right, asymptote. The asymptote for the parent function is y equals 0. I'm sorry, x equals 0. And I've not shifted up, down, or I've not shifted left or right. I don't have any horizontal transformation, so it's still going to be x equals 0. Let's see if we can make that better. Okay, so let's connect and approach. Okay. Goodness, I put all of these in the wrong. Had those in the wrong column. Okay, so let's do domain and range now. So this time, remember, you can only take log of a positive number. So you can see also graphically my domain is 0 to infinity, not including 0. But your range for logs is going to be all real numbers, okay? All right, let's talk end behavior. Now be careful, because notice your domain does not go from negative infinity to infinity. It goes from 0 to infinity. So that's what your x's are going to approach here. So let's do infinity first. As we go to the left for the right forever, y's go up forever. So this is still going to be infinity. It grows very slowly, but it does grow forever. And then here I cannot go as x approaches negative infinity. Instead, the left bound here is not negative infinity anymore, it's 0. So I need to say limit as x approaches 0 of f of x. And when we approach this asymptote, the y's go down forever. So the y's approach negative infinity. Okay? All right, I want to just go through those last few, like what would, when you're finding your 2 points, what would you make x be? So for here, remember, first try to make the inside be 1. So if the inside is going to be 1 here, then I would want to test x equals negative 2, right? For the next one, you want to do powers of your base. So in this case, your base is e. So I want to start with the inside being e. That would be x equals e minus 3, right? Shall we do that one together? So when x is e minus 3, then y is ln of e minus 3 plus 3, right? Because I still have this, which is ln of e, and ln of e is 1. Yeah, remember, any log base of 1 is always 0, and ln of e is 1. Okay, for 11, again, look at your inside. You're going to say, okay, what x makes the inside be 1? Well, that would just be 1, okay? Next, go with powers of your base. So go x equals 4. If you want a third point, the next power of 4 is 16, right? So you're basically doing this to the 0, this to the 1, this to the 2, etc. That's how I'm getting these x values, okay? All right, for your 2 points for number 12, again, what's going to make the inside be 1? Well, that's going to be -1, right? Your base here is e, so now you say, okay, let's go powers of e. Well, if I make the inside be -e, then I've got ln of e, which again, from up here is 1, right? Then I can just add 1 on the outside. All right, hopefully that gets you all started on that. I'll see you next time.